A rocket is being launched repeatedly to test its landing capabilities. If the landing mechanism fails with a probability of 0.1, what is the probability that out of 4 tests, there is exactly 1 failure during landing? Okay, so we can see we're dealing with these sort of Bernoulli trials. We've got something that is performed repeatedly. We've got the same probabilities over and over again. Okay, so the formula we're going to need is n choose k, p to the k, 1 minus p to the n minus k. Now, knowing a formula is great, but what is n, what is k, what is p, where do I find them in a question? Okay, how can I actually understand what to do here? So n is the number of times you're repeating this experiment. In this case, we've got 4 tests, so n is going to be equal to 4. Okay. Now, p is the probability of what we're interested in counting. Okay. What do we want? We want exactly 1 failure. Okay, so we're counting failures. Probability of failure of the landing mechanism is 0.1. Okay. And k is the number of times you want this particular outcome. In this case, we want exactly k equals 1 failure. Okay. So now we've got the 3 numbers we need. We can put it all together. 4, choose 1, and choose k, p to the k times 1 minus p to the n minus k. So we've successfully put our numbers into the formula. Now we can clean up. 4 choose 1 is 4. Anything to the power 1 is just itself. 1 minus 0.1 is 0.9, and 4 minus 1 is 3. And that's our answer. We're not going to simplify it any further. Of course, if you wanted to, you could. 4 times 0.1 is 0.4, and then 0.9 to the power 3 is 0.729, and you can multiply the decimals out as you like. But you could leave it simplified like that. You could probably even get away with leaving something simplified like that. Although usually you clean up the 4 minus 1 and the 1 minus 0.1. So I guess it's really up to you whether or not you want to simplify the 1 up here and the binomial notation in front. But there we go.